Welcome to Next Gen Manufacturing. We're going to talk about something that sounds incredibly simple today, drilling a hole. I mean, how hard can it be, right? But what if that hole needs a bottom that is perfectly 100% flat? Well, that's when things stop being simple and the engineering gets really, really cool.
So think about any standard drill bit you've ever seen. It always has that pointed tip, and that is absolutely by design. You'll usually see a 118-degree angle. That's your go-to for general work. Or maybe a slightly sharper 130-degree point if you're trying to push through tough stuff like stainless steel. That point is designed for one job, to pierce the material and guide the drill straight.
And here they are, side by side. On the left, you've got the classic pointed drill bit we all know. But on the right, that's our star for today, the flat bottom drill. Its cut-in face is a perfect 180 degrees. It's totally flat. And that one little change in geometry, it completely changes the kinds of things you can build. All right, so that brings up the big question. Why on earth would you ever want to get rid of that super efficient point? What are the situations where a flat bottom isn't just nice to have, but is the only way to get the job done? Well, the most common reason is for something just like this, a socket head cap screw. If you want the head of that screw to sit perfectly flush with the surface, you have to machine a little recess, a counterbore. And if you use a pointed drill for that, you'll be left with a cone shape at the bottom, and that screw is just never going to sit flat. It'll wobble. Now, if you know a little about machining, you might be thinking, hold on, why not just grab an end mill? I mean, they look flat, right? Seems like it would work. But this is where precision manufacturing gets tricky. Using the wrong tool, even if it looks right, can lead to big problems. So yeah, they look kind of similar. Why can't they do the same thing? The answer, it turns out, is a hard no. And the reasons why are actually super important for understanding how these tools work. First off, an end mill is designed to cut side to side, not to just plunge straight down. Because of that, it's terrible at getting the chips out of the way. They just get all packed in there. And get this, it's not even truly flat. It's actually a little bit concave, so it'll leave a tiny little dimple right in the center of your hole. Plus, they're just not made for drilling deep holes. They don't have the length. So if an end mill is out, what did machinists do for years before all this fancy new tech came along? Well, they did what they've always done. They relied on pure skill, a steady hand, and a whole lot of ingenuity. It was a true art form. And this is how they did it. All by hand, on a bench grinder. It's a three-step dance. First, you take a standard high-speed steel drill bit and very carefully grind that pointed tip right off. Then, you'd have to thin out the center part, what's called the web, to create a new cutting edge. And finally, the trickiest part, you'd have to grind the proper relief angle on each side. It's all about feel and experience. It takes a ton of practice to get right. But even if you made the perfect tool, using it was a whole other challenge. You couldn't just go in and drill the flat-bottomed hole from scratch. No, you had to first drill almost all the way down with a regular pointed drill. Then you'd swap in your hand-ground bit just to finish off the bottom. And since these tools clog up easily, you had to peckette it, drilling a little, pulling all the way out to clear the chips, going back in, over and over again. It was slow. That old-school craftsmanship is amazing for sure, but man, was it time-consuming. Modern manufacturing just demands more speed, more accuracy, more consistency. And this is where next-gen tooling just completely rewrites the rulebook. The first huge leap forward was the switch to solid carbide drills. We're talking about a much tougher, more rigid material. But the real game changer? A lot of them have these tiny channels running right through the tool that blast coolant directly at the cutting edge. That single feature blows the chips out of the way instantly, which means you can say goodbye to pecking forever. So, what does getting rid of pecking and using a better material actually get you? How about a massive speed boost? These new solid carbide drills can cut 5 to 6 times faster than those old hand-ground high-speed steel tools. 5 to 6 times. That is a gigantic leap in productivity. And this chart just lays it all out so clearly. You start with a hand-ground HSS drill. It's slow, it needs a pilot hole, and you have to peck. Then, boom, solid carbide comes along. 5 to 6 times faster, no more pecking, though you might still need a pilot hole for deeper stuff. But then you get to the top of the mountain, the modular drill. This is it. This is the state-of-the-art for flat bottom drilling. A modular drill is kind of the best of all worlds. It has a tough steel body that you can reuse with a small, replaceable solid carbide tip.
This setup gives you unbelievable performance and versatility, letting you do jobs that used to be a massive headache or just plain impossible. And, this new technology isn't just about making the same old parts faster. It's about unlocking totally new designs and engineering solutions that, honestly, just weren't very practical before. With these modern tools, you can pop a perfect blind hole for a sensor to sit in. You can punch clean holes through thin metal plates for things like heat exchangers. And maybe the most impressive thing, you can drill straight into an angled surface and the drill won't wander off. It just goes. You can even create perfectly intersecting holes, which is absolutely critical for making complex parts like hydraulic manifolds. Someone came up with a fantastic line to describe this whole shift. It's time to flatten the drilling curve. It's a clever little phrase, right? But it perfectly captures what's happened here. We've moved from a slow, difficult, manual process to something incredibly fast, precise, and totally predictable. And that's what I want to leave you with. From the tiny electronics packed into our phones to the massive hydraulic systems that power heavy machinery, this one very specific manufacturing trick plays a hidden but totally essential role. It really makes you wonder, doesn't it? What other amazing technologies that we use every single day are only possible thanks to the ability to make a simple, perfectly flat hole?